there, this is Mrs. Baker's Chemistry Corner, Monster Paper 4, and it is question 2. Solutions of ionic compounds can be broken down by electrolysis. Concentrated aqueous copper 2 chloride was electrolyzed using the apparatus shown. So it's got platinum electrodes which are inert, and it's got copper 2 chloride. The ionic half equations for the reactions at the electrodes are shown. So at the negative electrode, the copper ions are picking up electrodes and going to copper metal. So we've got 2 plus going to 0, which is a decrease. Therefore, it is reduction. And we've got the minus 1 going to 0. So that is an increase. Therefore, it is oxidation. Platinum is a solid which is a good conductor of electricity. State one other property of platinum which makes it suitable for use as electrode. So we've got the good conductor. We need to say that it is inert. It is inert. That's all you need. State what would be seen at the positive electrode during this electrolysis. Well, we've got chlorine gas being formed, so you will get bubbles, because it's a gas, of greenish gas formed. That's what you would see at the electrode. State and explain what would happen to the mass of the negative electrode during this electrolysis. Well, at the negative electrode, we're picking up copper. So state and explain means you have to say what would happen and tell us why. So you get 1 mark for stating, 1 mark for explaining. So mark 1, the mass would increase. State 2, that's stated what would happen to the mass. Now we need to explain why. So we say, because the copper metal would be deposited at the cathode. So the concentrated aqueous copper 2 chloride electrolyte is green. Suggest what would happen to the colour of the electrolyte during this electrolysis and explain your answer. Okay, so you've got copper 2 ions. They're a greeny blue. You're going to get 1 mark here for suggesting what would happen to the colour and another one for explaining your answer. So, mark 1, let's suggest what would happen. Remember, we've got inert electrodes up here. So, we're going to, the colour would fade over time. Why would the colour fade? Well, now we need to explain our answer. So, we start with because it's an explanation. Because the copper ions from the electrolyte are being used up. You could also have turned into copper. Okay, because they're not being replaced. Identify the species that is oxidized during this electrolysis. Well, if we go back to our original, the species that was being oxidized here is the chloride ions. So the chloride ions are being oxidized. Why do we know that they've been oxidized? Well, oxidation is loss, so we can have loss of electrons. We could also have here, don't forget that we've got an increase in oxidation number, so you could also put increase in oxidation number. It means the same thing. So however you worked it out in your, have to put B in there, however you worked it out in your head, both of these answers will get you the mark. Metal objects can be electroplated with silver. Describe how a metal spoon can be electroplated with silver. Include what to use as the positive electrode and the negative electrode, what to use as the electrolyte, and an ionic half equation to show the formation of silver. You may include a diagram. Anytime it gives you space and says you may include a diagram, that means that you are gonna get marks for a diagram. It's an easy way to get marks. So let's draw a diagram because it's told us to, right? So let's draw one electrode as the silver metal. And now let's draw one electrode as a spoon. Brilliant drawing there, Mrs. Baker. Let's put the external wires and the battery in and attach them to our electrode. Now let's draw our electrolysis cell. Let's put our electrolyte in and let's now label the diagram because that's where we're getting our marks from. So here, electrolyte. Now explain what you could use. Well, if you're electroplating with silver, you're going to need a dissolved compound of silver. So the easiest one is AgNO3 or silver nitrate. Let's label the spoon. Let's label the pure silver. Now, which one do we have as the anode and cathode? Well, we know that the pure metal in electroplating is always the anode, and the spoon must be the cathode in this case. So let's see, what have we already got our mark for? What to use as the positive electrode and negative electrode? We've already got the mark because we've said we need a pure silver anode and we need the spoon as the cathode. What to use as the electrolyte? Well, we've already got that because we've already said silver nitrate. Now we need an ionic half equation to show the formation of silver for the last mark. So ionic half equation to show the formation of silver means at the cathode. So we're going from silver metal to, we're picking up an electron and we're going back to silver metal because we're going from positive to negative. Have we got the correct amount of marks? Let's see. We've got 1 here, 2 here, 3 here, 4 here. Everything present and correct. Oh, RTFQ Miss Baker should have put the half equation there. Give one reason why metal spoons are electroplated with silver. Well, there are many answers that you could give here. One would be to increase resistance to corrosion. We electroplate anything to increase resistance to corrosion. And of course, we don't want our spoons to corrode over time. But also, it could be to make them look more expensive than they really are, or make them look prettier, I guess. Silver is also antibacterial, so you could get a mark for saying antibacterial, but it's only silver that's antibacterial. So I wouldn't worry too much about trying to remember that fact. Always go for either resistance to corrosion or to make them look more expensive or make them look nicer, improve the appearance. Okay, that is question 2, full marks.